Hi, I'm Tommy Skoski, and I'm going to walk you through the shooting reconstruction um, expert testimony. And there's 5 questions here, and let's start off with how does the um, scientific method apply to shooting reconstruction? First, you will want to identify the problem. So if you walk into a crime scene and there's a firearm, there's some fired bullets, and there's a victim with a gunshot wound, um, you would want to ask yourself, did this firearm fire these bullets and cause the harm to the victim? Next, you'll want to make an observation and say, based off what I see it's a 22 caliber firearm. There's 22 caliber fired shell casings and bullets, and um, there's a bullet hole in the victim. So I believe that there could be a correlation between all of them, and that could have caused the harm to the victim. Next, you want to make a hypothesis and say, I believe this 22 caliber firearm fired these bullets and caused this harm to the victim because when I did my um, initial walkthrough, I found that it's all matching up. There's a 22 caliber firearm, 22 caliber shell casings and bullets, and it seems like everything could match up, and that could be a good hypothesis. Next, you'll want to carry out the test, send everything to a lab, have them determine with their expertise what they believe happened, and see if the rifling and everything match up with the bullets. Um, and that will help you refine your hypothesis, which is the 5th step in the scientific method, and that is going to reinforce your hypothesis and basically determine if you are correct or not. Next, you will want to develop a theory, and that's the final step, and that is going to be determining, yes, my theory is correct based off all the evidence, everything I've collected, it's all matching up, and I believe that this firearm fired these bullets, caused this harm to the victim. So the next question is how to calculate the angle of impact. And you're going to do this first by dividing the width by length. And so let's take, for example, the width is 0.46 millimeters, or inches, or whatever you want to use. And then the length is 0.92, and you would divide that. You will get a number and apply sin to it, sin, and that's going to give you an angle of 30 degrees. And so another thing to determine with that is if you have an angle of impact at 90 degrees, that is going to create a circle type shape in the object. But as the angle gets lower, you're going to want to keep in mind that the lower the angle under 90 degrees, it's going to create a more oblong and a more long and stretched out type shape, where 90 degrees is going to be more straightforward, a circle, and as it gets lower, more oblong, more stretched out. And so the next question is, how does a revolver work? Well, a revolver is a type of firearm. Let's take a double action revolver, and it holds 6 bullets. So the revolver is going to be round, and the shell casings, or the bullets are all going to fit in to the revolver, which when you pull the trigger on the double action, the hammer comes back, and as the trigger is fully pressed, the hammer is going to come back and then release, hit the center of the shell casing, causing an explosion and pressure to build up, which when that pressure exceeds the the friction from the bullet sitting inside, the pressure is going to build up and it's going to send the bullet through the barrel of the gun, which there's the rifling to keep in mind. There's going to be a right hand or a left hand twist, which you can further analyze after you shoot it. And basically when that pressure builds up, it's going to shoot, and it's going to go through the barrel of the gun. The revolver is a little bit different because it's circular and it holds the bullets in there. There's magazine would be a little bit different. That's going to hold the bullets, and when you shoot, the next one's going to pop up because of the spring in the magazine. This is circular, and when you shoot, the next one's going to twist and be ready to go for you to fire again. So that is how a revolver works. The next question is, what is the difference between internal, external, and terminal ballistics? Well, let's start with internal ballistics. That is the study in what happens inside the firearm when you shoot it. So let's start. It's the study of combustion, pressure, and motion. So essentially, when you pull the trigger, the hammer is going to hit the cartridge, which causes an explosion. There will be pressure, and there'll be pressure and gases that build up, and when they exceed the friction from the bullet sitting in there, it's going to explode, and the bullet's actually going to expand just a little bit, and as it goes through the barrel of the gun or of the firearm, the lands and the grooves are going to twist the bullet, making it more accurate when it exits the barrel. So the lands and the lands and the grooves. The rifling will either have a right hand twist or a left hand twist, and that essentially means, is the bullet twisting to the right or to the left? And an easy way that you can analyze that, if you find a fired bullet, would be to look at it, and if the grooves are twisting to the right, then it is a right hand twist, and if they move to the left, it would be a left hand twist. And the lands are in between, like when you're looking at the bullet, it's in between the grooves, and it's the part that pops up. And so you could have like a 6 groove, like a 6 groove twist. So a 6 groove right hand twist. It twisted to the right, and there's 6 grooves and 6 lands, which would make up the internal ballistics. The external ballistics are, so you start with looking through the scope of the firearm, and that is your line of sight. That would be exactly where you want to shoot at the target. And so it's going to be aimed perfectly at the target, and that is a straight line from what you see to your target. And the initial point is from the time it leaves the bullet. That would be the initial point where I'm going to refer to. When you fire, the bullet is actually going to be on an upward angle, and it's going to be moving up and out of the barrel. And as pressure and gravity all play a role on that bullet, it's actually going to dive down just a little bit. Obviously, we're talking on a very small scale, and the peak of that bullet after it leaves the barrel is called the mid-range, and that's the peak that the bullet will have in height before it takes a dive. The critical zone is the zone that you would be aiming at your target, basically. The zero zone is where my line of sight and the trajectory match up. That's the point where that bullet is going to hit. And then the back curve is actually behind, so that would be further than the zero zone. And that would be past the target when it actually goes beneath the line of sight. That would be the back curve. The terminal ballistics refer to what does the bullet do as it hits an object. So let's take the human body as an example. There's a temporary cavity and a permanent cavity. And that basically, when a bullet hits the human body, it's going to open up and then it's going to come back, because our bodies are made kind of like a gelatin type material because of the tissue, the body tissue, the fat, everything, the skin, that would act as like a gelatin type material. And as the bullet enters, the human tissue spreads apart, but then it comes back together. But the permanent cavity is actually the part that doesn't come back together, and that is what actually creates the bullet hole when you look at the human body. That will never come back together. And so when the bullet comes through, a lot of people think high velocity versus low velocity. High velocity would cause a lot more damage and have a deeper impact on the body. It's not necessarily true. Low velocity can actually do a lot of damage. As the bullet enters, the bullet can actually rotate, and that's why a lot of times if you see an entrance wound, it is a lot smaller than the exit wound, and it doesn't necessarily match up. It's not a perfect line because that bullet kind of fumbles around inside the body, and that can actually cause a lot of damage. So when you look at it, it creates a cone type, it kind of looks like a cone. The entry wound is very small, but it blows out as it exits, if it did exit your body. So it's kind of like a cone shape, where the entrance is smaller than the exit. So that is the difference between internal, external, and terminal ballistics. So to move on to the next question, which would be how can you tell that a shell casing came from a certain bullet? So this is kind of what I said earlier about the rifling and the lands and grooves. Rifling, you can have the right hand or left hand twist on that, which would be looking at the grooves, and if they move to the right, it's a right hand twist. If they move to the left, it's a left hand twist. The raised area are known as lands, and that basically comes in between the grooves. Cut rifling and hammered rifling are the two main different types of rifling that you would see. The cut rifling is a round edge, and this could be like, let's say we take for an example, like a six cut rifling. This would be more like rounded edges, whereas hammered would be more squared. So you would send that bullet to a lab, and you'd take that gun to a lab, and you would analyze what kind of twist, what kind of land, what kind of grooves the bullet has, what kind does the firearm have, and if they match up, looking at it underneath a microscope and matching up perfectly, whether the lands, grooves, the right hand, left hand twist all match up, that would be a good way to analyze and see what if your bullet matches up with your firearm. And so we have went over what is the difference between internal, external, and terminal ballistics, how to tell if a shell casing came from a bullet. We described if a revolver, or how a revolver works, the angle of impact, how to measure that, width and length, divide that and apply sine to that, and you will get the angle of impact, and how to apply the scientific method to shooting reconstruction. So that is my expert testimony. Thank you.